right, I'm going to go over the test here so that you can look at the problems that you need to look at to figure out what you did wrong, and if you're making corrections, you can fix them. All right, so question one. The way I would have solved this is starting by multiplying the entire inequality by 12. 12 is the least common denominator of 6 and 4, so that's why I was going with 12. I know a lot of people were just plugging in these values and testing the inequality, and that didn't seem like the most effective way. I noticed a lot of mistakes when people were doing that. So if you solved it like this, you could cross simplify. 6 goes into 12 two times, and then you would distribute to the x plus 3. And then greater than the other side, 4 goes into 12 three times, and then here you would essentially multiply by the x. There's nothing to distribute to. And then this part here, you do have to multiply the 12 times the 1. So that would be plus 12. All right, so this essentially is 3x plus 12, right? So 12 times x over 4 is 12x over 4, which is 3x. And then you're also multiplying the 12 by the 1. All right, the other side, when you distribute this, you would get 2x plus 6. Okay, you could do this whatever way you want as far as your process of solving. I would get rid of the 3x on the right side. I'd have negative x plus 6 is greater than 12. Subtract the 6. All right, I'm going to move this over here. Negative x is greater than 6. Then divide by negative 1. And you did need to remember here that when you divide by a negative, you must flip the sign. So you get x is less than negative 6. Now, if x is less than negative 6, it means it has to be a number smaller than negative 6. Oh, it's a little blurry. There we go. This is obviously not smaller than negative 6. Neither is this. A handful of people got negative 6, but then they picked that x should equal it, and it shouldn't, right? It should be less than, so that's why it's A. All right, up here, or down here, I should say, the gardening club at school is growing vegetables. The club has 300 square feet of planting beds. Cucumber plants require 6 square feet of growing space, and tomato plants require 4 square feet. The students want to plant some of each type of plant and have at least 60 plants. Select all the equations and inequalities that could be used to describe this situation. Okay, so if they're going to have more than 60 plants, we would definitely want to go with cucumbers plus tomatoes is going to be greater than or equal to 60. Now, they only have 300 square feet of space, so we would need the 6 square feet per cucumber and 4 square feet per tomato to be less than or equal to 300. Now, the one that a few people missed was this one here. It was saying that you have to have more than 0 cucumbers. They told us that they want to plant some of each type, so they're going to plant more than one of each type. This one would not work because we don't want to have less than 0 tomatoes, but we do want to have greater than 0 cucumbers. Okay, this keeps going in and out. Hopefully you can see it all. For this one, most people were fine on this, but there were a few people that didn't graph the line correctly. What I would have done here is just the x and y intercept, because 4 and 5 are both factors of 20. So to graph the y-intercept, I would make x 0, and y would have to be 4. 5 times 4 is 20. Okay, if I wanted to graph the x-intercept, I would make y 0. So I would, cover up the y, because 5 times 0 is 0, and 4 times what is 20, and that is 5. So here would be your 2 points. If you had a straight edge, you'd probably make your line nice and straight. Mine, it's not quite as straight, but it is a dashed line. Okay, if you forgot to make a dash, that was, a point off. Then testing the point, because you had to shade. There were a couple people that forgot to shade. So if you forgot to shade, you needed to test a point like 0, 0. If you plug 0 in for x and 0 in for y, you would get 0, and 0 is less than 20. So you would want to shade below our boundary line because that's where 0, 0 is. All right, moving on to page 2. All right. This one here, multiple choice question. So you had to figure out the shading part. So the top equation was the solid line. If you looked, all the lines were essentially the same. So it was essentially just the shading that you were trying to figure out. This top equation, if you were to put it in slope-intercept form, it would be y is greater than or equal to 3/5 x minus 3. Okay, now if y is greater than 3/5 x minus 3, you would want to shade where 0, 0 is, because that would be true. 0 would be greater than or equal to -3. So shading above the line. So shading above, right? So essentially these two are my only two options at this point because these two shaded below. For this one, if you plugged in 0, 0, you'd have 0 is greater than 1. That is not true. So you would want to shade below your, or sorry, not below, because here's the dashed line. You would want to shade where 0, 0 is not, and that is above the line. So here's, the solid line, we shaded above. Here's the dashed line, we shade above as well, because again, we don't want 0, 0 to be in our shaded space. All right, and the one that does that is B. In A, it's shaded for the dashed line below, which is where 0, 0 is, which would mean 0, 0 is a solution here, and it's not. Okay, down here, this one, people did really well on this, and you guys came up with a lot of different possibilities where you could have 30 haircuts or less and still make, or I guess the stylist, I shouldn't say you, but the stylist would make at least $360. So like I said, there was tons of possible options here. You were essentially looking into this space right here to find a combination. So like you could do 25, 0, you could do 25, 2. That would be 25 adult haircuts, 2 children haircuts. Like I said, tons of possible answers. If you got something wrong, it's because you picked a point that was not in this space. Like maybe you picked a point here, or you picked a point in this white area, or I don't know. If you picked a point that was not here, then you didn't get it right. But most people, like I said, did, and there was lots of combinations that you could have gone with. Okay, over here. So biggest problem here is that some people didn't answer both questions. It was like people answered this one and then thought that was what this was also asking, but they're actually asking something different. This one was saying, so you guys know it's about making jewelry for selling necklaces at an art fair. It's $135 to rent the booth. The cost of the material for each necklace is $450, and she's selling for $12. So here's the inequality. They set it up for you. That was nice. You didn't have to do that. But it wants to know, is she going to make a profit if she sells 15 necklaces? So you would have to plug in the 15 for N and essentially solve it. And you could have used your calculator. That would have been fine. If you did this, you would essentially get that $180 would be how much she'd make, but it's costing her for those 12 necklaces $202.50. So the answer here is no, she will not make a profit. So most people were A-okay on that one. What happened was some people just didn't do this. They were like, yeah, I solved it right here. I saw like some arrows going up where what it wanted you to do is actually figure out how many necklaces does she need to sell to make a profit. So if you were to solve our inequality, you would, at least my process that I took is to subtract the 450N. It's kind of your choice on how you go about it. You'd have 750 n left and 135 over here. Divide by the 7.5. And n needs to be greater than 18. So essentially she needs to sell more than 18 necklaces. Okay, if she sells 18, she's not making a profit, right? She needs to sell more than 18 to make a profit. All right, down here, this was the last one. So they graphed, or I guess let's write the inequalities first and then we'll talk about the graph. So the lawn care business, $15 per hour for mowing lawns, $20 per hour for gardening. He can only work 20 hours per week because he's still in school, but he wants to make $300 within that time. So we could use, and again, it's kind of up to you. You could use L for lawns. Could have used X for lawns too. They have, X down here. That would have been fine. G for gardening. Or you could have used Y. There's the Y-axis. So either one of those I was accepting. So the first equation, which most people had, was the $15 times however many lawns plus $20 times however much gardening. And that has to be greater than or equal to 300 because he wants to make $300 or more. The second equation was something that a few people didn't write. And some people actually graphed it, but they didn't show the equation. So you were also supposed to write, and I shouldn't say equation, inequality for the hours that he can work. And so between the two types of, things that he's doing, he can only work 20 hours. So this amount has to be less than or equal to 20. Okay, so this line here was essentially our graph for this top inequality. If you did your X and Y intercept here, the Y-intercept was at 15. Okay, so that's, if you were to do 0 mowing, he could do 15 hours of gardening. Or if he was going to do 0 hours of gardening, so essentially 20 times 0, 0, he could then do 20 hours of lawn mowing. All right, so that was this one, right? This is the 20 and the 15. So then for this one, if he's going to do 0 lawn mowing, he could do 20 hours of gardening. Or if he was going to do 0 lawn mowing, he could do 20 hours of gardening. Did I say that right? 0 lawn mowing, 20 gardening, 20, 20 mowing, 0 gardening. Sorry, I'm looking at this on the iPad and it looks backwards. Anyways, okay, so that would be 0, 20, or 20, 0, and 0, 20. Sorry about that. And this is a solid line. Oh boy, that was a terrible line. Let's make that better. All right. Really could use my straight edge here. Did not bring it home. All right, so there we go. All right, so we still have to shade. So we drew the graph in. Good. Now it said down here to show all the points. For this, I was just looking for the overlapping shaded region. So for our first equation that was talking about the amount of money he makes. So he wants to make greater than or equal to $300. If you tested 0, 0, it would not be true, right? 0 is not greater than or equal to 300. So for this first line, you would want to be shading above the line. Okay, but he has to work less than 20 hours. So if you plug 0, 0 in here, that is a true statement. So we would be shading below this line that I drew in. So that would be here. So ideally, you made it nice and dark so that I could tell exactly where that overlapping region was, and it would be right there. Okay, and that is our last question. Yeah, I think that's it. Make sure you guys, a few people had hours, like H for hours up here, just like adding in this third variable that wasn't needed. So, you know, these are two variable situations. We had it written down here, mowing lawns and gardening. So just, you know, make sure that when you're setting up these equations, or inequalities, I should say, that you are only using the variables that are necessary. All right, the extra credit, not going to spend a whole lot of time on this because it was from, it's so blurry. It was from, there we go, last unit. But just for you to see, you were making a row total. It wanted a row relative frequency. So you needed to get your row totals, create the percents for each of those, and then compare the columns. All right. Okay, that is it. Thanks for watching. Bye-bye.